Tonight you will fall asleep, and you will miss it. Nobody has ever caught the exact instant their awareness goes out. You have tried. Here is the strange part. Physicists have spent 40 years arguing whether that same one-way blindness applies to the end of a life. Whether, from the inside, an ending can ever be experienced at all. The answer runs through one equation taken at its word, one number measured inside the brain, and a wager no physicist will take. It starts with tonight. According to the deepest equation in physics, read literally, you are being copied. Not once, not occasionally, constantly, silently, every fraction of every second, as the universe splits into branch after branch, and a version of you rides into each one. That is not science fiction embroidery. It is the plainest reading of quantum mechanics' own arithmetic, a reading called the many-worldsinterpretation. And it has sat in the technical literature since 1957, defended by some of the most capable physicists alive. And inside that reading hides a further claim, whispered more than published, a claim we are going to take apart tonight with honest tools. That because none of those branches can ever contain your absence, as experienced from within, your awareness is condemned to continue. The idea is called quantum immortality. Most of the physicists who built the branching picture reject it. The reasons they reject it are stranger and more beautiful than the claim itself. Keep tonight's falling asleep moment in your pocket as we go, because in 2 hours that ordinary, unwatchable fade will return to decide the entire argument. Begin with the mechanism before any history, because the title's claim rests on a specific chain of physics, and you deserve to see the chain before anyone tells you where it breaks. The first link, quantum mechanics says small things exist in superpositions. An electron does not sit here or there. Until measured, it occupies a genuine blend of here and there, and this is not a statement about our ignorance, but about the world. The mathematics that describes the blend is called the wave function, and every laser, transistor, and MRI machine on Earth is a monument to how accurately it works. The second link is the trouble. When you measure the electron, you never see the blend. You see here, or you see there. One outcome, definite, single. So what happened to the other half of the wave function? The textbook answer, drilled into physics students for a century and named after the city of Copenhagen where it was argued into shape, says the wave function collapses. Measurement forces reality to choose, the unchosen possibility evaporates, and the dice roll is genuinely random. The collapse answer works flawlessly in practice. It also has a hole in its center that a century of effort has not filled. Nobody can say what counts as a measurement, when exactly the collapse happens, or why a universe that runs on smooth, deterministic mathematics should reach in and delete its own possibilities. Physicists call this the measurement problem, and it is the deepest open wound in the foundations of the field. The wound has a mascot, and you have met it, Schrödinger's cat. It is worth 30 seconds to remember what the cat was actually for, because popular culture has inverted its meaning. In 1935, Erwin Schrödinger, whose own equation started all this, proposed the scenario meant as a protest, not a marvel. Seal a cat in a box with a single radioactive atom, a detector, and a mechanism that links the atom's decay to the cat's survival. The formalism, taken literally, describes the sealed system as a superposition, a blend of cat alive and cat gone, until someone opens the box. Schrödinger's point was, this is obviously ridiculous, therefore something about applying the wave function to big things must be wrong. He offered the cat as a reductio, an absurdity that would shame the theory into confessing its limits. 70 years later, the theory has confessed nothing. Superpositions have been demonstrated in objects large enough to see in a microscope, in currents flowing 2 directions at once around superconducting rings, in molecules of thousands of atoms. The absurdity keeps scaling up and keeps refusing to break. Everett's move, seen against the cat, was simply to stop flinching. If the formalism insists both terms are there, then both terms are there, cat included, and the only question is why we never feel like both. Hold that question. Its answer, decoherence, is coming, and it will turn out to be the same answer that dismantles tonight's paradox. In 1957, a Princeton graduate student proposed the most radical repair imaginable: no repair at all. His name was Hugh Everett III, 26 years old, working under the legendary physicist John Wheeler. Everett asked what happens if you simply take the equation at its word. No collapse, nothing ever deleted. The wave function of the entire universe just keeps evolving, smoothly, forever, exactly as the mathematics says. Then what happens during a measurement? The equation answers without blinking. The measuring device joins the blend. And the physicist reading the device joins the blend. The universe does not choose between outcomes. It keeps both, and the physicist splits with it, one version seeing here, one version seeing there, each certain their result was the only one, forever unable to meet. What does that actually mean for you, sitting in your room? It means that if Everett was right, every quantum event with more than one possible outcome is quietly splitting the world, and you with it. The universe is not a line. It is a branching tree, and what you call your life is one path through it, while other versions of you, sharing your entire history up to each fork, walk the others. Is that not obviously absurd? Ask what the absurdity actually consists of, because the answer is uncomfortable. The picture offends intuition, but it uses fewer assumptions than the textbook story, not more. Copenhagen needs the Schrödinger equation plus a collapse rule bolted on. Everett needs only the equation. His interpretation is quantum mechanics with a postulate removed, and that economy is exactly why it refuses to die. Physicists have spent 70 years trying to dismiss the branching picture, and it keeps returning, because the alternative is to explain what collapse is, and nobody can. Here is the equation everything hangs on, spoken plainly, because you should hear how small it is. The Schrödinger equation, IH bar d psi by dt equals h hat psi. Psi is the wave function, the complete description of a system's state. H hat is the Hamiltonian, the accounting of the system's energy. The left side says, how does the state change in time? The right side answers, smoothly, predictably, determined completely by the energy. Picture a vast, perfectly calm harbor at night, and every possible history of the world as a ripple pattern spreading across it. The equation is the physics of the water, and the physics of the water never destroys a ripple. It only ever spreads, splits, and interferes. Collapse would be a hand reaching down to slap half the harbor flat. Everett's entire proposal was one sentence long: there is no hand. And now the whispered corollary, the one this video exists to examine. If the harbor never loses a ripple, then among all the branching paths of the tree, there are always branches in which any given observer continues. Always. However improbable the survival, the equation's arithmetic keeps a sliver of wave function in which it happened. And here the argument makes its decisive move, the move every critic will later attack. It says, consider what an observer can experience. A branch in which you continue contains a moment of experience. A branch in which you do not contains, for you, nothing at all. No darkness, no silence, no waiting room, simply no experiencing subject. Non-existence has no inside. So, the argument concludes, from the first-person point of view, awareness can only ever find itself in branches where it persists. The other branches are real, and in them the people who love you grieve. But you, the argument claims, are never there to notice. Experience threads itself through the surviving paths, always, automatically, like water finding the channels that remain open. What does it mean that a deterministic equation, with no opinion about minds at all, can be read as a guarantee that your point of view never ends? Sit with how strange the claim is, and notice what it is not. It is not a claim about medicine, or about anything a doctor could measure. Every third-person fact stays exactly as grim as before. The claim lives entirely in the first person, in the question of what comes next for the one having the experience. And that is precisely what will make it so hard to test, so seductive, and, as the second half of this video will argue with the field's own numbers, so probably wrong. I want the honesty on the table this early, because this channel does not sell mysteries it cannot pay for. The idea you just heard, subjective survival through the branches, is a contested minority position. The physicist who formalized its sharpest version now rejects the personal survival reading. The philosophers who built the modern mathematical case for many worlds, the very people with the most to gain if the argument held, are almost uniformly against it. What this video offers is not a promise that you cannot end. It is something better, the full argument, the exact places it breaks, and the one narrow question that genuinely remains open. Plus 3 numbers, one from inside your skull, one from a tank of water under a mountain in Japan, and one from the far end of time. Together they turn a spooky claim into one of the most clarifying stories in modern physics. So who dares to make a claim like this in print? The lineage matters because it is not a lineage of cranks, and the story begins with the man who built the tree.
Hugh Everett III was born in November 1930 in Washington, D.C., and he was, by every account, ferociously and impatiently brilliant. At Princeton in the mid-1950s, he drafted a doctoral thesis under John Wheeler, the physicist who mentored Richard Feynman and later named the black hole. Everett's draft said, in effect, that the emperor of quantum orthodoxy had no clothes. Collapse was an invention, and the universal wave function, evolving alone, was the whole of reality. Wheeler believed in the mathematics but feared the philosophy, and he made Everett cut the thesis to a quarter of its length before he would accept it, in March of 1957. The published version, titled with deliberate mildness, The Relative State Formulation of Quantum Mechanics, appeared that summer in Reviews of Modern Physics. In 1959, Wheeler carried the idea personally to Niels Bohr in Copenhagen, the living father of the orthodox view. The visit went badly. Bohr's circle regarded the branching universe as somewhere between confusion and heresy, and Everett, stung and proud, walked away from academia entirely. He spent the rest of his career in defense analysis and operations research, a man who had proposed the largest picture of reality in the history of physics, working out the mathematics of weapons logistics. He smoked, drank, and by his own philosophy did not need to worry. His biographers report, and this is a biographer's account, not an established fact, that Everett privately believed the branching structure meant his own point of view could not be extinguished. Hugh Everett III died of a heart attack in 1982. He was 51 years old. Hold that dissonance, we will return to it. Because what Everett allegedly believed and what his equation actually licenses are exactly the gap this video measures. The theory itself outlived its author's exile. In the early 1970s, the physicist Bryce DeWitt championed Everett's work, gave it the name that stuck, Many Worlds, and put it in front of a generation. And the generation bit, slowly at first, then hungrily, because 2 developments began repairing the theory's soft spots. The first was decoherence, which we will meet properly in a while, a mechanism explaining why the branches stop interfering with each other and become, in every practical sense, separate worlds. The second was a run of serious attempts to explain how probability works in a universe where everything happens. Keep that phrase, how probability works, close at hand. The entire fate of quantum immortality will turn on it. Before the lineage of the survival argument, we should be honest about the belief this whole topic presses against, because you hold it, and you hold it for the best possible reasons. The belief that an ending is a final switch-off, that when a life ends, experience simply stops, completely, and that this is the one certainty available to every human being. Where does the belief come from? From everything you have ever observed. You have watched awareness switch off and on in yourself, through anesthesia, through dreamless sleep.
Classical physics treats a person as one body following one history to one end. Every instinct, every observation, every equation you learned in school agrees. Holding this belief is not a failure of imagination. It is what the evidence of an entire human life looks like from the inside of a single branch. And now, the careful statement of what quantum mechanics does and does not do to that belief, because this is where a lesser video would start lying to you. The branching argument does not disprove the switch-off picture. What it does is expose how many hidden assumptions the picture rests on. For the certainty to hold as stated, the universe must keep only one copy of you. Endings must be clean binary events, and the question, what will I experience next, must always have a straightforward answer. Quantum mechanics, on its most economical reading, denies the first assumption outright, and the second and third turn out to be far shakier than anyone suspected. The honest correction is precise. Your certainty rests on assumptions the physics makes genuinely murky. That is not the same as physics showing you cannot end. Hold the difference. The entire 2 hours lives inside it. There is one more tool you need before the story accelerates, and it is the single most important concept in this video. When a branch splits, the two offspring are not equals. Each branch carries a number, inherited from the wave function's arithmetic, called its amplitude, and the rule that connects amplitude to experience is the second equation of the night, the Born rule. Probability equals the modulus squared of the amplitude. Spoken even more plainly, square the branch's amplitude and you get the chance of finding yourself there. Max Born wrote that rule down in 1926, and it is the most exactly verified statement in all of science. Every prediction quantum mechanics has ever made runs through it. Think of the branching tree as a river delta seen from above. The water splits and splits again, but not evenly. Some channels carry almost the whole flow, others are trickles you could step across. The squared amplitude is the flow. Physicists working in Everett's picture call it the measure of a branch, its weight, its share of existence. Keep the word measure in your pocket next to the falling asleep moment. When the survival argument finally stands trial, measure will be the prosecution's star witness. If you are enjoying this journey so far, a quiet tap on subscribe helps more of these deep explorations reach curious minds, and costs you nothing tonight. Now, the lineage. Ideas like subjective survival do not enter physics through the front door, and this one arrived 3 times, independently, through 3 different side doors, before anyone dared formalize it. The first quiet mention came in 1986, when the British physicist Ewan Squires discussed the strange first-person logic of branching in his book, The Mystery of the Quantum World. 2 years later, the idea appeared in earnest, and from outside physics entirely. Hans Moravec was a roboticist at Carnegie Mellon University, one of the founding thinkers of machine intelligence. In his 1988 book, Mind Children, he followed the branching logic to its conclusion in cold print. Our consciousness continues to exist in some of those worlds, he wrote, and we will always find ourselves in worlds where we exist, and never in ones where we do not. Read that sentence twice, because it is the entire argument in miniature. Not a mechanism that saves you, but a selection effect, a bias built into where experience can be found at all. Around the same time, a Belgian logician named Bruno Marchal reached the same cliff from yet another direction, without using quantum mechanics at all. Marchal reasoned about minds as computations. If a mind is a process that can run, then wherever in reality that process runs, the mind finds itself, and the first-person view inherits a deep indeterminacy about which copy it is. Marchal presented this in Toulouse in 1988, and again in Paris in 1991. And his version matters because it reveals something the quantum dressing hides. The survival argument is not really about quantum mechanics. It is about what happens to the concept of what comes next for me in any picture of reality that contains more than one of you. Everett's tree just happens to be the most respectable such picture physics has ever produced. It is worth one slow breath to appreciate how strange that convergence is, because ideas do not usually arrive 3 times. A physicist in Britain, a roboticist in Pittsburgh, and a logician in Brussels, working in different decades of the 1980s, in different formalisms, with different motivations, each followed their own reasoning to the same precipice. That in any reality containing multiple instances of a mind, the phrase, "what happens to me next," stops behaving. When independent roads meet at the same cliff, the cliff is usually real, and this one is. The cliff is genuine. What the rest of tonight will show is that the cliff is not where the survival argument thinks it is. The argument believes the cliff overlooks a guarantee of continuation. The field's 25-year survey of the terrain found something else at the bottom, a lesson about the limits of the word me. What does it mean that 3 unrelated thinkers, hunting 3 different problems, all tripped over the same crack in the concept of personal identity? It means the crack was always there, running under every human sentence about the future, and physics merely built the first structure heavy enough to make it show. If the ground under the word me is starting to feel less solid than it did an hour ago, hold on to one ordinary handrail as we go. Nothing in your practical life is different tonight. Your calendar, your responsibilities, the people expecting you tomorrow, all of it sits in this branch, governed by the same odds as ever. The vertigo is real, but it is conceptual, the good kind, the kind that comes from seeing the machinery under a floor you will keep walking on either way. Physics regularly does this. It did it when the solid table turned out to be mostly empty space, and the table kept holding dinner. The table will hold tonight too. And then, in 1997, the argument finally got its formal wardrobe. Max Tegmark, a young Swedish-American cosmologist who would go on to a professorship at MIT, wrote the paper that named the sharpest version of the idea, in an article with the mischievous title, "The Interpretation of Quantum Mechanics, Many Worlds or Many Words." Tegmark's contribution was a thought experiment of surgical precision, built to do one thing: separate clean quantum branching from the messy gradualness of real biology. Let me describe it exactly as the literature does, as a formal construction on paper, because that is what it is and what it must remain. Imagine a device that measures a single quantum property, the spin of one particle. A property that is a perfect 50-50 superposition until measured. Couple the device to an outcome so absolute and so fast that in one branch the experimenter's awareness continues uninterrupted, and in the other branch there is, within a millisecond, no experiencer at all. Nothing gradual, nothing partial. The wave function after one run is the third equation of the night, and its shape is the whole point. 1 over root 2 times spin up and alive plus 1 over root 2 times spin down and gone. 2 terms, equal amplitude, one containing an observer and one containing none. Picture a ledger with 2 columns written in the same ink, except one column has a reader and the other column is a page no one will ever turn. That asymmetry between the columns, not any physical force, is the entire engine of the paradox. Now run the logic from each side of the interpretational divide and watch the 2 pictures of reality tear apart. Under the textbook Copenhagen view, each run collapses the wave function, one outcome, chosen at random. The experimenter survives the first run with probability 1/2, 2 runs, 1/4, 10 runs, about 1 in 1,000. After n runs, the survival probability is 1/2 raised to the n, a curve that dives towards 0. which is why every sane account of the experiment ends with an obituary. But under Everett's reading, there is no collapse and nothing is chosen. Both terms of the wave function are real after every single run. And so, with certainty, not probability, certainty, there exists after 10 runs a branch, measure 1 in 1,000 and shrinking, in which the experimenter stands entirely unharmed, having watched the device come up safe 10 times in a row. The mathematics guarantees that branch's existence, the way it guarantees the thin channel at the edge of the delta. Almost no water, but never dry. Tegmark's point, and be careful here because popular retellings mangle it, was not that anyone should believe in subjective survival. His point was that the two interpretations seem to make different first-person predictions in exactly one exotic circumstance, which would make the interpretation question for the first time feel empirically meaningful to a single stubborn observer, while remaining forever invisible to everyone else. From the outside, both interpretations predict the same thing, a run of luck ending, sooner or later, in tragedy witnessed. Only from the inside, and only if a chain of assumptions holds, does the branching picture whisper, "You will find yourself in the surviving column, always." What does it mean that the most tested theory in physics can be pushed, in 10 lines of algebra, to a place where its own architects start disagreeing about what the word "you" refers to? Notice what has actually happened. Nothing exotic was added to quantum mechanics. The paradox was assembled entirely from standard parts: superposition, branching, and the innocent-sounding question of what an observer should expect to experience next. Which means the paradox is not a bug in some fringe theory. It is a crack that runs through the foundations of the mainstream one, and the field's best minds have spent 25 years arguing about what leaks through it. And the first thing that leaks through is a warning from the man himself. Tegmark, who formalized the experiment, does not believe it applies to you. Within a year of his paper, he was already pointing at the assumption the whole engine hides inside the phrase "within a millisecond." Real biology, he observed, is not a two-column ledger. And the demolition of the paradox begins, of all places, with a number Tegmark himself would soon measure inside the human brain, a number so hostile to quantum romance that it did not just wound the immortality argument, it ended an entire theory of consciousness on the way. Before the demolition, clear away the 4 objections that are probably queuing in your mind, because they are the right objections, and each has a real answer. Are the other branches actually real places? On Everett's reading, yes, exactly as real as this one, and no branch is the original. But real does not mean reachable. Once decoherence has done its work, the branches cannot signal each other, interfere with each other, or be visited even in principle, and this is not a rule added to protect the theory. It follows from the same mathematics that makes your computer work. Practically, another branch is real the way the interior of a black hole is real, a consequence of equations you can trust, forever outside your inbox. Does the endless splitting violate the conservation of energy? No, and the accounting is elegant. Think of the wave function's total as a fixed estate being subdivided among heirs. Each branch carries a thinner slice of amplitude, the measure you have been pocketing all night. Nothing is created. The inheritance is diluted. Within any branch, energy books balance perfectly, which is why no experiment inside a branch can feel the splitting. Is this the same multiverse as the cosmological ones, the other bubbles from inflation theory, or the mirror universe this channel explored recently? No. Those are proposals about distant regions or reflected copies of ordinary spacetime, places in the same physical arena. Everett's branches are not elsewhere in space. They are parallel terms in the universal wave function, overlapping the very room you are in, separated not by distance, but by decoherence. When physicists are careful, they call the cosmological kind a multiverse of places, and the Everett kind a multiverse of histories. And the question under all the others, if the branches are unreachable and undetectable, is any of this science? The honest answer has two halves. The interpretation makes no new testable predictions, which is exactly why it remains an interpretation rather than a discovery, and why this video keeps flagging pole numbers instead of measurements. But the reasoning is scientific in the strict sense. It takes the equations every physicist already trusts and refuses to add anything to them. Many worlds is what quantum mechanics says when nothing is added. Whether that austerity is profound or merely stubborn is, as you have seen, a question the field itself has not settled. To understand Tegmark's number, you now need the machinery that builds the branches, because branching is not magic, and it is not instantaneous everywhere at once. It has a mechanism, a rate, and an architect. The mechanism is called decoherence, and it answers the question skeptics rightly ask of Everett. If superpositions are real, why have you never seen a coffee cup in two places? Here is the answer. A superposition survives only as long as the system keeps its quantum information to itself. The instant the system interacts with its environment, one stray photon bouncing off it, one air molecule grazing it, the environment learns which alternative is which, and the two components of the superposition stop being able to interfere. They decohere, still both present in the universal wave function, but now dynamically deaf to each other, evolving as separate effective worlds. Picture two orchestras sharing one concert hall, playing different symphonies. While the hall is sealed, the sounds tangle and beat against each other, and you hear the interference. Open every door and window, let the sound bleed into a noisy city, and each orchestra's music decays into the background differently, until no listener anywhere can reconstruct the beats. The symphonies did not stop. They lost the ability to touch. That loss is decoherence, and it is not philosophy. It is measured daily in every quantum computing lab on Earth, where engineers fight it with cryostats and vacuum chambers, because decoherence is precisely what kills their qubits. The architect who turned this into a full theory of how classical reality emerges is Wojciech Zurek, a Polish-American physicist at Los Alamos. Zurek showed that the environment is not a passive nuisance, but an aggressive editor. Interaction relentlessly destroys most quantum states and spares only a special few, the pointer states, the stable configurations that survive being watched, a process he named einselection, environment-induced selection. And he pushed further, into a framework with a name this channel's viewers have met before, quantum Darwinism. The environment does not just select the survivors, it copies information about them outward, redundantly, in fragment after fragment, photon after photon. Many observers can each catch a different fragment and agree on what they saw, and that agreement is what objectivity is. Why does a chair have one definite location for everyone in the room? Because the light bouncing off it has broadcast that location in millions of redundant copies. The classical world, in Zurek's picture, is the universe's most aggressively published document. Notice what this machinery quietly establishes for our question. An observer, in branching physics, is not a ghostly point that hops between worlds. An observer is a macroscopic, hot, wet, constantly monitored physical system, embedded in an environment that copies its state outward billions of times per second. Whatever the survival argument wants to claim about where awareness finds itself, it has to survive contact with that picture of what an observer physically is. Keep the phrase constantly monitored. The trap it sets is about to close. And Zurek's framework answers a question the survival argument prefers not to be asked. What, physically, holds an observer together as one thing through time? Not a thread of spirit stuff. Nothing in the equations plays that role. What persists is a pattern, a pointer state stable enough to survive the environment's relentless monitoring, redundantly documented in the surroundings from moment to moment. Your physical continuity in this picture is a matter of the environment's bookkeeping, trillions of overlapping records agreeing, instant by instant, that the same configuration is still here. Now watch what happens to that bookkeeping in the scenarios the immortality argument cares about. As a biological system degrades, the pattern's stability degrades with it. The records the environment keeps become records of a different, diminishing configuration. There is no moment when the bookkeeping flips a single bit from present to absent. The documentation simply, gradually, comes to describe something else. Ask the question the cartoon version never asks. If being an observer is a matter of degree, maintained by degrees of environmental record, what exactly is the thing whose survival the argument guarantees? The argument needs a crisp, all-or-nothing passenger. Decoherence theory, the very machinery that makes the branches, provides only a pattern with fuzzy edges, thinning by degrees. The deeper you look into how worlds are actually built, the less there is for the survival claim to be about. What does it mean that the theory which creates the many worlds also refuses to define a sharp someone to survive in them? File that with the measure problem. The two greatest strengths of the Everett picture, its decoherence machinery and its weight arithmetic, are precisely the two instruments that take the immortality reading apart. Because now we can ask the question with teeth: how fast does decoherence actually work inside a human brain? This was not an idle question when Tegmark took it up in the late 1990s. A famous proposal by the physicist Roger Penrose and the anesthesiologist Stuart Hameroff had argued that consciousness itself might be a quantum phenomenon, that microtubules inside neurons could sustain delicate superpositions, and that the mind might literally run on quantum computation. If that were true, the immortality argument would gain a foothold, because a genuinely quantum mind might plausibly track, ride, or even exploit branching events. So Tegmark did what physicists do to romantic hypotheses. He calculated. The paper appeared in Physical Review E in the year 2000, and it is a masterpiece of brutal bookkeeping. Tegmark modeled the brain's candidate quantum states, ions moving through neural membranes 10 nanometers thick, superpositions of a neuron firing and not firing, microtubule states. For each, he computed how long it could keep quantum coherence inside the brain's actual environment. Warm, salty water, crowded with jostling molecules, about as far from a shielded laboratory vacuum as physics allows. The answers came back between 10 to the minus 13 and 10 to the minus 20 seconds. Now place beside that the timescale on which neurons actually do anything, 1,000th to 1/10 of a second. Feel the size of the gap before the numeral lands. It is the gap between 1 second and, at the extreme end, 3 million years. 10 orders of magnitude at minimum, 17 at the far end. The brain destroys quantum superpositions at least 10 billion times faster than it can complete a single elementary act of thought. Take a breath and let the consequence unfold, because this number is doing two jobs tonight. Job 1. It retired the quantum mind hypothesis as originally proposed. Whatever consciousness is, it is not a fragile quantum computation, because no such computation survives a nanosecond in brain tissue, let alone the milliseconds a thought requires. The brain is, in the precise technical sense, a classical object, decohered, monitored, published to its environment countless times between any two of its own heartbeats of cognition. Penrose and Hameroff's defenders responded, and the exchange stayed in the journals, but the mainstream verdict has held for a quarter century. Cognition rides far, far above the quantum layer. Job 2 is the one that matters for our story. The survival argument, in its seductive telling, imagines awareness at a fork. The world splits, and experience, unable to enter the empty branch, slides into the surviving one. But look at the timescales. The split completes in less than a trillionth of the time a single thought takes. Consciousness does not stand at the fork. Consciousness is a slow, lumbering, classical process, stitched together across millions of branching events that are each over before a single neurotransmitter has crossed a single synapse. By the time you finish experiencing this very word, the tree has branched beneath you more times than there are grains of sand on Earth, and you noticed nothing, because the noticing machinery lives 10 floors of magnitude above the branches. What does it mean that the self the argument wants to escort through the fork cannot even perceive that forks exist? It means the picture of awareness riding the branch is not physics. It is a cartoon drawn at the wrong scale. I will be honest about what this number does and does not kill, because the argument's defenders have a real reply. They can say, No one claimed consciousness perceives the branching. The claim is only about where experience is found after the fact, a selection effect over the tree, not a passenger on it. That reply is fair, and it is why this video does not end here. But something important has already died. The intuitive engine of quantum immortality, the mental movie of your awareness approaching a lethal split and swerving into the safe lane, is physically incoherent. Whatever survives of the argument must be rebuilt in colder language, amplitudes, measures, and the statistics of successors. So that is where we go next, into the heart of the mathematics, where the many worlds picture faces its deepest internal reckoning. The problem that decides not just this paradox, but whether the interpretation itself can speak the language of probability at all. I know the ground we just covered was dense, so set it down for a moment. All of tonight's machinery, branches, amplitudes, decoherence rates, is in service of one question you could ask while brushing your teeth. When I wake up tomorrow, why am I so sure it will be me? The physics of the next hour is, at bottom, the physics of that certainty, of what the word me is allowed to mean in a universe that keeps carbon copies. Hold your toothbrush skeptically tonight. The question is older than quantum mechanics. The equations just made it unavoidable. Now, the measure problem stated plainly because it is the deepest weakness of the many worlds interpretation and, in a twist the immortalists did not anticipate, also the source of the strongest argument against them. Here is the problem. In Everett's universe, everything permitted happens. Flip a quantum coin weighted 99-1 and both outcomes occur, each in its branch, each containing a version of you. So what could it possibly mean to say the rare outcome had 1% probability? It happened, with certainty. Somewhere in the tree, a version of you sees it, every single time. Repeat the experiment 1,000 times, and the tree contains branches with every conceivable frequency of outcomes, including branches where the 1% event came up every time, and a bewildered copy of you concludes that the laws of physics are broken. Everett called these the maverick branches. They are guaranteed to exist. Why then do we, the versions of us having this conversation, see clean Born rule statistics? Why does squaring amplitudes of all operations tell us what to expect? The critic David Albert pressed this objection into its sharpest form. In a theory where every frequency is realized, the claim that Born rule frequencies are what you should expect looks dangerously close to unexplained bookkeeping. Make Albert's worry concrete, because it deserves to be felt rather than summarized. Imagine a quantum coin, weighted so the mathematics assigns heads an amplitude whose square is 99%. Flip it 1,000 times. In a collapsing universe, you expect roughly 990 heads, and the rare deviant runs are genuinely improbable. In the branching universe, the tree after 1,000 flips contains every sequence. All of them. Somewhere there is a branch with 1,000 tails in a row, and standing in it, a copy of you, staring at the record, who has just watched a 99% coin fail 1,000 consecutive times. That copy has done nothing wrong. Their observations are real, their notebooks are accurate, and if they reason from their evidence, they will conclude, rationally, that the laws of physics are different from what they actually are. Now the uncomfortable question, and do not rush past it. How do you know tonight that you are not in one of the maverick branches? The regularities you call the laws of nature, the constants measured to 12 decimal places, the Born statistics themselves, all of it is, on the branching picture, the testimony of the particular channel you happen to occupy. The Everettian answer leans entirely on measure. Maverick branches exist but carry vanishing weight, and rational credence follows weight. Which is consistent and perhaps even satisfying until you notice that this is precisely the principle the immortality argument must violate to get off the ground. The immortalist asks you to follow a vanishing weight channel because of what it contains. The maverick branch analysis says following vanishing weight channels because of what they contain is exactly the mistake that would make science impossible. One principle, two applications, no exceptions available. Whichever way you rule, you must rule the same way twice. The branching universe, it turns out, forces a package deal. Either measure governs expectation, killing quantum immortality, or it does not, killing the very notion that observed frequencies teach us physics. The field chose measure, and it did not choose it to spite the immortalists. It chose it because the alternative dissolves the laboratory.
At this point, a sharp viewer raises the objection that deserves the most careful answer of the might, so let me voice it at full strength. Someone has to be the trickle. The maverick branches are inhabited. The Thousand Tales observer is real, and from inside, their experience is exactly as vivid as yours. So when the mortalist says, expect the high measure branches, is that not just the majority shouting down real minorities? By what right does weight translate into expectation for me when some version of me is guaranteed to be the exception? Feel the force of it, because this is the immortality argument's soul in its most defensible form. And now watch the answer, because it is one of the quiet triumphs of the past 20 years of Foundation's work. The question, by what right does weight govern expectation, is precisely what the Deutsch-Wallace theorem, the caring measure, and the self-locating hotel argument each answered from independent directions. Any agent who reasons otherwise, who weights branches by count or by drama or by content, can be money-pumped, Dutch-booked, and led into incoherence by their own lights. The exceptional branches are real, and their inhabitants are not wrong to exist. They are simply guaranteed losers of a lottery that rationality still obliges everyone to price by the odds. There is a version of this insight older than quantum mechanics. An insurance actuary does not deny that some client will live to 106. The actuary denies that anyone is entitled to plan as if they are that client. The branching universe, for all its extravagance, adds exactly one thing to the actuary's table: the certainty that the outliers are somewhere out there in the tree. It subtracts nothing from the table itself. Existence, the mathematics keeps insisting, was never the question. Weight was. The Everettians answered with three of the most interesting arguments in modern foundations. David Deutsch in Oxford, later joined and refined by the philosopher David Wallace, argued from decision theory. A rational agent inside a branching universe, caring about their successors and obeying a handful of consistency axioms, is forced, mathematically forced, to weigh future branches by exactly the squared amplitudes. Probability on this reading is not painted onto the world. It is the price list rationality writes for itself when the world branches. Hilary Greaves at Oxford sharpened the same thought into the language of a caring measure. You cannot avoid the question of how much to care about each of your descendants, and the only consistent exchange rate is Bourne's. And Charles Sebans and Sean Carroll approached from a third door, self-locating uncertainty. And their door is worth walking through slowly, because it is the one place in this whole subject where you can actually feel the mathematics from the inside. Picture waking in a hotel with perfect amnesia about which room you are in. You know the hotel, 2 identical rooms, same wallpaper, same view, and you know that last night a coin decided which room got you. Nothing about your experience distinguishes the rooms. What confidence should you have that you are in room 1? Every bone in your reasoning says 1/2, and says it necessarily, because assigning anything else would mean letting your confidence depend on a fact you have no access to. Now the quantum version. In the instance after a split, before any result reaches your senses, there are already 2 of you, physically identical down to the last neurotransmitter, each in a branch, each ignorant of which. That interval of ignorance is not exotic. Decoherence guarantees it exists after every measurement, everywhere, always. What credences should such a copy assign?
Sebens and Carroll proved that the hotel principle, that confidence must not depend on inaccessible facts, pins the answer uniquely to the Born weights. Your confidence in each branch must equal its squared amplitude, not because anything is random, but because that is the only self-consistent way for a copied mind to locate itself. 3 roads, 1 destination. Even in a universe where everything happens, the squared amplitude is what a reasoning mind must treat as the odds.
The critics, of course, kept pressing, and their pressure produced its own strange offspring. David Albert, with Barry Lower, proposed in 1988 that if the mathematics will not yield probability, perhaps the minds must. Their many-minds-interpretation attached to each observer a continuous infinity of mental threads, distributed across outcomes in Born proportions. Most of the field found the idea more expensive than the problem it solved, but it shows how seriously the difficulty was taken. Hilary Greaves named the underlying ailment the incoherence problem. Before asking whether the Born rule is the right probability rule, one must ask whether probability means anything at all in a universe with no uncertainty about what happens, only about where in the happening you are. And the physicist Don Page, working his own furrow, reframed the weights in language tonight's question will need. In a branching universe, he wrote, the quantum probabilities are not chances for histories to occur, since all occur. They are measures for the magnitude of existence of each history. Sit with Page's phrase, magnitude of existence. It suggests, unsettlingly, that existence in a branching world is not a yes or no property, but a quantity, something a history can have more or less of, and every argument about what you should expect is secretly an argument about how experience distributes itself over that quantity. What does it mean that physicists debating a probability rule found themselves forced to ask how much a world exists? Notice how far beneath the immortality question the excavation has gone. We came for a spooky claim about survival and found the foundations of chance itself under renovation. None of these derivations is uncontested, and this channel will not pretend otherwise. Critics argue the decision theory axioms smuggle in what they prove, and the debate is alive in the journals. But notice the shape of what the many worlds camp built, because it is about to be turned against the immortality argument like a key turning in a lock. Every road to probability in Everett's universe runs through measure. Your rational expectations, your care for your successors, your bets about what comes next, all of it must track the flow of squared amplitude through the delta. And with that, the stage is set for the trial. Because the quantum immortalist now has to answer a question phrased in the theory's own language. When most of the flow runs into channels where you have no successor, what exactly entitles the trickle to claim your whole expectation? The prosecution's case opens with the man who wrote the argument down. Max Tegmark, within a few years of formalizing the thought experiment, published his verdict on its real-world application, and his reasoning cuts at the joint the paradox depends on. The experiment works, he observed, only because it forces an abrupt transition. In one branch, an observer, in the other, within a millisecond, none. Under normal circumstances, he wrote, an ending is not a binary thing. Biology does not flip a switch. It dims a dimmer, cell by cell, function by function, across seconds, hours, sometimes years, and every intermediate setting of that dimmer is a physical state the wave function happily includes. Redraw the ledger honestly, and the two clean columns dissolve into a continuum of columns, branches with successors in every stage of decline, branches with partial awareness, faint awareness, flickering awareness, and, only at the far edge, branches with none. The selection effect argument said experience threads itself into branches that contain an experiencer. Very well, replies Tegmark. Then in any realistic scenario, the overwhelming weight of experiencer-containing branches are the ones in which you are simply diminishing, by the ordinary route, with the ordinary odds. In his own later words,
Even if one cannot end all at once, one can gently fade away. The argument that promised a guarantee of continuation delivers, at best, a guarantee already available from biology, that fading is gradual from the inside. The paradox needed a cliff. Reality is a slope. Pause on the arc of the man delivering that testimony, because it is a case study in how science is supposed to metabolize its own provocations. And it happened in full public view across 3 acts. Act 1, 1997. Tegmark, the young cosmologist, formalizes the sharpest version of the survival paradox, not to endorse it but to expose how strange the interpretation question becomes when pushed to the first person, and ends the paper noting the experiment only distinguishes anything under assumptions nobody can verify. Act 2, the year 2000. Tegmark, the calculator, publishes the decoherence timescales of the brain, and personally installs the largest single obstacle the survival reading would ever face, the 10 orders of magnitude wall between branching and thought. Act 3, 2014. Tegmark, the senior physicist, writing his book on the mathematical universe, states plainly that real endings are gradual, that the abruptness his own thought experiment required is a laboratory fiction, and that he does not expect the paradox to apply to any real life, his own included. Ask yourself what it costs a scientist to spend 17 years dismantling the most famous idea attached to his name, and then ask what it would have paid him to do the opposite: the lecture circuit, the book sales, the mystique of the physicist who proved you cannot end. He declined the whole estate. When this video weighs testimony, that is why his weighs heaviest. Consider what this does to the seductive version of the claim. Picture a sandcastle before the tide. The Immortalist's cartoon imagined a single wave that either vaporizes the castle instantly or misses it entirely forever. The real tide takes the castle the way tides do, a little from the base, a corner, a wall, in 10,000 small collapses spread across the evening. At no single instant is there a fork labeled exists and exists not, with awareness swerving down the safe tine. There are only millions of micro-forks, in almost all of which the castle is slightly smaller. Branching physics, applied to real biology, does not predict escape. It predicts erosion, distributed across the tree exactly as the born weights dictate.
The second witness is the philosopher Charles Sebens, co-author of the self-locating derivation you just met, and his objection is a scalpel. The survival intuition, he notes, has surface plausibility only if the lethal outcome and the branching are absolutely simultaneous, so that there is never a moment of a doomed successor existing to have expectations. But if there is any delay whatsoever, even a microsecond in which both successors exist and think, then the doomed copy is a full-fledged experiencing person during that interval, and rationality must count them. And decoherence has already told us the branching completes in under a trillionth of the interval any biological process needs. In every physically realizable case, there is delay. The idealized simultaneous case, the only soil where the intuition grows, does not occur in nature. Sebens's conclusion is quietly devastating. If there is any delay, the expectation of survival should be rejected. The third witness speaks for the theory's own bookkeeping. Lev Vaidman, the Tel Aviv physicist who authored the field's standard encyclopedia entry on many worlds, and who takes the interpretation as seriously as anyone alive, states the measure argument without decoration. The large measures of the worlds with dead successors are a good reason not to play. Notice what Vaidman is doing, because it is subtle and it is the heart of the mortalist position. He is not denying that a surviving successor exists in some branch. He is denying that bare existence buys expectation. In the delta of branching futures, your rational anticipation, your planning, your care must flow with the water, not with the topology of the channels. A trickle-thin branch containing a survivor is real. So is a lottery jackpot branch. You do not budget your life around either, and for exactly the same mathematical reason.
Then comes the objection from identity itself, pressed by Sean Carroll. The survival argument speaks of your awareness continuing, as if there were a single thread to follow through the tree. But Everettian mechanics, read carefully, says something different. When the world splits, distinct persons come into existence, each descended from you, none uniquely you. Asking which one is really me, Carroll argues, is like asking which of two rivers is really the lake they drained from. The question mistakes ancestry for identity. And once you see successors as descendants rather than as a relay baton, the moral arithmetic changes. Ending the existence of some of your descendants is a loss, in a branching universe exactly as in a single one, which is worth objecting to, Carroll notes dryly, just as it would be anywhere else. The philosopher David Papineau completes the demolition from within the Everett camp. Nothing in the mathematics licenses editing your expectations when some branches lack successors. You should expect a future branch where you perish, he writes, to just the same degree as you expect a future branch where you survive. The physicist Jacques Millard gave the fallacy a full-length treatment in 2009, arguing the immortality inference simply cannot be extracted from many worlds at all. And David Deutsch, the closest thing living many worlds has to a founder, locates the exact hidden premise. The argument requires the additional assumption that when making decisions, one should ignore the histories in which the decision-maker is absent. My guess, Deutsch says, with the mildness of a man dropping a keystone, is that the assumption is false. Pause and take inventory, because something remarkable has happened. Every one of those witnesses, Tegmark, Sebens, Carroll, Weidmann, Papineau, Deutsch, is a defender of the branching universe. These are not Copenhagen partisans mocking a rival's excess. These are the people with the most to gain if their theory implied something as spectacular as guaranteed continuation. And they are the ones lining up to say it does not. In science, the provenance of an objection carries information. When a claim is rejected most firmly by the community whose worldview it would glorify, the rejection is not prejudice, it is quality control. And yet the prosecution is not finished, because the strangest witness is still waiting, and his testimony is not that the argument fails. It is that if the argument somehow succeeded, you should be horrified. The witness is David Lewis, and his credentials matter. He was, by wide agreement, the most influential metaphysician of the 20th century's second half, a philosopher who spent a career mapping possible worlds with an engineer's rigor. No one alive was better equipped to take a many-worlds argument exactly as seriously as it deserved. In 2001, in the last lecture he gave before his own passing, a lecture published after it under the title, "How Many Lives Has Schrödinger's Cat?", Lewis walked further down the survivalist road than its friends ever dared, precisely in order to show where it leads. Suppose, he said, the selection effect were real. What exactly is selected? Branches where awareness persists, not branches where health persists, not branches where you remain yourself in any sense worth wanting. The Greek myth had already mapped this territory. Tithonus granted unending life without unending youth, aging forever into a husk that could not end. Lewis called the corollary terrifying, and the label has stuck in the literature. If experience always finds a channel, the channels it finds, in overwhelming measure, are the ones where the dimmer keeps dimming without reaching zero. Ever narrower, ever diminished states of being, sustained not by mercy but by arithmetic. The dream of quantum survival, examined honestly, is not a dream at all. Among its own believers, it converts instantly into the strongest imaginable argument for hoping the theory's critics are right. The final witness closes the loop with your own evening. The cosmologist Anthony Aguirre points out that the survival argument, if it worked as advertised, proves catastrophically too much. Awareness diminishes every single night. Sleep, anesthesia, concussion, deep meditation, every one of these is a branch-by-branch dimming of the very experience the argument says can never dim away. If first-person expectation truly could not flow into experience-poor branches, you should find yourself unable to fall asleep tonight, forever locked into wakeful branches by the same selection effect. You will fall asleep tonight. You do every night. The argument's own logic, tested against the one ending-like transition every human being rehearses daily, fails before breakfast. Aguirre's summary deserves quoting for its plain sanity. Perhaps reality actually is this bizarre, he allows, but it would be foolish and selfish in the extreme to let this possibility guide one's actions in any life and death question. There, in one sentence, is the entire responsible position, and this channel repeats it in its own voice. Nothing in this video is a reason to treat any risk differently. The physics, as you have now heard at length, does not support the wager, and the community that understands the mathematics best refuses it unanimously.
What does it mean that an argument about the deepest equation in physics is finally undone by the fact that people sleep? Sit with the humility of that. The falling asleep moment you pocketed at the start of tonight turned out not to be a poetic anchor. It is a datum, a nightly experiment 7 billion humans run against the immortality hypothesis, and the hypothesis loses every single night. It is worth running that nightly experiment in slow motion once, with everything you now know, because it assembles the whole evening's physics into a single, familiar scene. You lie down, awareness begins to thin, and it thins classically. Chemistry accumulating, neural gates closing, cortical rhythms slowing, a dimmer turning through continuous settings, none of them a quantum fork. Beneath this, all night, the branching hums along at its own impossible tempo, worlds splitting in femtoseconds, and your slow, warm, decohered brain does not register one of them, because it cannot. The wall between the tempos is 10 orders high. In the tree of tonight, there are branches where you sleep well, branches where you wake at 3 in the morning, branches, at vanishing measure, where any number of unlikely things occur, and the weights across those branches are exactly what medicine and actuarial tables always said they were. Somewhere in the fade, there is a last noticed moment, and then, hours later, a first noticed one, and memory will splice them seamlessly, the dashboard camera swearing the engine never stopped. Where were you in between? The question sounds deep and is, you can now see, malformed. There was no experiential between, and no rule of physics obliged one to exist. The selection effect did not keep you awake. The measure did not thin toward wakeful branches. You dimmed on schedule, in nearly every branch, at nearly full weight, and the universe carried the rest without your supervision. If awareness could not survive a night without the immortality mechanism's help, the mechanism would have revealed itself long ago. It has never once been needed. That is the quiet, nightly, 7 billion-fold verdict, and no thought experiment outweighs it. Before we leave the night behind, one more turn of the same key, because it opens the last door of the argument's psychology. Why does the survival claim feel so plausible at first hearing, when the physics against it is this lopsided? Because it borrows its plausibility from a true premise, that you have never experienced an ending, and never will. The move from that truth to, therefore my experience continues, is a single, slippery step, and tonight has shown exactly where the slip happens. It confuses a limit on what can be reported with a law about what can occur. The dashboard camera never films the parking. It does not follow that the car never parks. Once you see the step, you cannot unsee it, and the claim's spell breaks permanently, which may be the most practically useful thing this topic teaches. A trained ear for arguments that turn the silence of a witness into testimony. But suppose, for the sake of thoroughness, that every objection you have heard was somehow answered. Suppose expectation really did thread itself through surviving branches. The universe has one more set of witnesses to call, and they do not argue philosophy. They argue infrastructure. Because an experience is not an abstract point, it is a physical process run on matter, powered by energy gradients, and the question of whether experience can continue without limit is, in the end, a question about whether the universe can keep the lights on. Physics has priced that question,
And the invoice is the most sobering document in this entire dossier.
Start with the schedule of the far future, as mapped by the astrophysicists Fred Adams and Gregory Laughlin in their classic study of the universe's 5 ages, and let the camera of the mind actually visit each age, because the immortality claim is a claim about all of them. We live in the stelliferous era, the age of stars, the bright morning of cosmic history, which runs to roughly 10 to the 14th years, 100 times a trillion. Every star you have ever seen belongs to this narrow, luminous opening act. When the last red dwarfs gutter out, their frugal fires finally spent, the degenerate era begins. A galaxy of corpses, white dwarfs cooling from diamond white to infrared to black, neutron stars spinning down in the dark, planets still faithfully orbiting suns that no longer shine. That era runs to about 10 to the 39th years. Then the black hole era, when even the dead stars have evaporated or been swallowed, and the only significant objects left are black holes themselves. Each one leaks away with impossible slowness through Hawking radiation. The largest take up to 10 to the 100th years, a number called a googol, to shine themselves into nothing. And beyond that, the dark era, a thin gruel of photons and stray particles, expanding, cooling, diluting, an arena in which the distance between any 2 remaining particles dwarfs today's entire observable universe. Every branch of Everett's tree, every single one, is subject to this schedule, because the branching multiplies histories, not resources. No channel of the delta escapes the drying of the riverbed. Before I continue, take a moment with that timeline and try a thought this channel finds clarifying. Locate yourself on it. If cosmic history were compressed into a single year, the entire age of stars, everything from the first sun to the last, occupies roughly the first second of the 1st of January. The remaining ages, the corpse light and the black holes and the dark, fill out the rest of the year. Whatever the word forever is doing in any survival argument, this calendar is the venue it would have to book. What would you conclude, looking at that calendar honestly, about any claim that experience continues without limit? And the schedule has teeth long before the googol mark. Matter itself may not last. Many unified theories predict that protons, the bedrock of every atom, eventually decay. Physicists have hunted this decay for decades in one of the great quiet experiments on Earth. Kamiokande, a cathedral-sized tank holding 50,000 tons of ultra-pure water, a kilometer underground in a Japanese mine, its walls lined with thousands of golden photomultiplier eyes watching the darkness for the telltale flash of a dying proton. Across decades of vigil, not one confirmed decay. That silence sets a flaw. The proton's lifetime in the channels tested exceeds 10 to the 34th years. For our question, the flaw cuts both ways. It means atoms outlast the stars by a gigantic margin. It also means that if protons do decay on any timescale at all, then well before the black hole era closes, there are no atoms, no molecules, no brains, no computers, no substrate on which any successor of yours could run. You cannot inhabit a branch that has no hardware. Could a sufficiently clever, far-future intelligence dodge the hardware problem, migrating to exotic substrates, slowing itself down, hibernating through the ages? This is not idle speculation. It is a real physics debate with named combatants and equations, and it gives us the final equation of the night. In 1961, the IBM physicist Rolf Landauer proved a result of stunning generality. Erasing one bit of information, anywhere by any means, costs a minimum energy of Boltzmann's constant times the temperature times the natural logarithm of 2. Spoken plainly, forgetting is never free, and the price is set by the temperature of the room. At room temperature, the price is 3/billionths of a trillionth of a joule per bit, invisible to daily life, but it is a flaw, not an estimate.
In 2012, a team in Lyon measured it directly, watching a single microscopic glass bead in a light trap dissipate exactly Landauer's minimum as it forgot 1 bit. Thought is computation. Computation must sometimes erase, and erasure burns fuel. Any experiencing process, biological or artificial, in any branch whatsoever, is a customer of this law. Now add the cruelest discovery of modern cosmology. The expansion of the universe is accelerating. An accelerating universe wraps every observer in a horizon with a temperature, a floor temperature that never reaches zero, no matter how long you wait. And with a temperature floor, Landauer's price never falls to zero either. The physicist Freeman Dyson had dreamed, in a famous analysis, that an intelligence could think forever on a finite energy budget by running ever slower and ever colder, an infinite retirement on shrinking interest. Dyson's scheme deserves a moment of admiration before its sentencing, because it is the most romantic calculation in physics. He imagined minds in the deep future deliberately slowing their own clock rate as the universe cools, thinking 1 thought per century, then per millennium, then per era, hibernating through the long stretches. Under the physics known in 1979, he proved the total subjective experience could still be infinite. A mind that slows in step with a cooling cosmos never feels the slowing, the way a dream does not feel the night passing. Infinite thought on finite fuel, bought with patience. Would such an existence even count as the continuation the survival argument wanted? Set the question aside as it deserves. The universe answered a different one first. Lawrence Krauss and Glenn Starkman ran the numbers for the universe we actually appear to inhabit and found the dream forbidden. With a temperature floor, each thought has a minimum cost, the energy budget is finite, and therefore the total number of thoughts any observer can ever have is finite. Dyson countered that sufficiently exotic, reversible computation might yet slip below the floor, and the dispute remains genuinely open at the frontier. But notice what the frontier is arguing about. Not whether experience continues by default, but whether even the most ingenious possible engineering could keep a mind running against thermodynamics. The Bekenstein bound adds the final wall. A system of finite size and energy can hold only finitely many distinct states, so an observer of bounded resources cannot even have unboundedly many different experiences. The far future on current physics is not a corridor stretching forever. It is a room with a measurable volume, and every branch of the tree is inside it. Let the 3 walls stand together, because their convergence is the point. The brain's decoherence rate says awareness cannot ride the branching. The measure mathematics says expectation cannot favor the trickle. And thermodynamics says that even the trickle, followed to the end of time, runs dry. The immortality argument asked physics for an exception, and physics answered with 3 independent refusals, from 3 unconnected corners of the discipline, at 3 wildly different scales: the nanometer, the abstract delta of amplitudes, and the entire future of the cosmos. When 3 doors close from 3 different hinges, the message is not subtle. There is one more feature of the survival claim that deserves its own moment under the lamp, because it explains why the debate lives in philosophy journals rather than laboratories, and it is best seen through a simple question. Suppose quantum immortality were true, what would the rest of us ever observe? Run it forward. In the branches available to any outside observer, the experimenter's luck runs out on schedule, statistics behave, actuarial tables hold, and every obituary reads exactly as it would in a single universe. The claim's entire content lives in a first-person channel no instrument taps. 2 colleagues could stand at the same funeral, one believing the survival thesis, one denying it, and no measurement in any laboratory on Earth could ever score their disagreement. Philosophers of science have a name for claims structured this way: unfalsifiable from the third person, and it is why even the argument's most sympathetic readers concede it sits at the very boundary of what the word science can be stretched to cover. Notice the asymmetry with everything else in this video. Decoherence rates, measured. The Landauer flaw, measured, with a glass bead in Lyon. Proton stability, measured, with 50,000 tons of water. The survival thesis, unmeasurable in principle by anyone, ever, except allegedly by you, once, with no way to publish. When a claim's evidential structure is a private channel with no receipts, physics does not call it wrong. It calls it something worse, undecidable, and moves on. Keep that word beside Page's magnitude of existence. Between them they mark tonight's true frontier, the line where equations end and the meaning of experience begins. I know these last stretches have been heavy, so before the verdict, one breath of ordinary air. Everything tonight ultimately roots through a piece of arithmetic you already run without noticing: how you weigh futures. When you buckle a seatbelt, decline a bet, take a slightly longer route because the shorter one has that intersection. You are distributing care across possible tomorrows in proportion to their likelihood. That is all the born measure is, dressed in formal clothes. The universe's exchange rate between futures, and the entire mortalist case tonight amounts to one sentence. No reading of quantum mechanics exempts you from the exchange rate. The branching universe, if it exists, does not change a single premium on a single policy. There is something quietly reassuring in that, and it is worth carrying out of tonight. The strangest theory in physics, pushed to its strangest corner, hands back the same advice your grandmother would have given. Live as if the odds are real. They are.
One more piece of context belongs in the record before the verdict, because you deserve to know how the field actually leans on the framework underneath all of this. The many-worlds interpretation itself, immortality aside, remains a minority position among working physicists. The polls tell a consistent story across a decade. In a 2013 survey of quantum foundation specialists, Copenhagen drew 42% and many-worlds 18%. A broader 2016 sample of over 1,000 physicists put Copenhagen at 39%, with many-worlds down at 6%. And in 2025, for quantum mechanics' 100th birthday, the journal Nature surveyed 1,100 physicists. Copenhagen 36%, information-based interpretations 17%, many-worlds 15%, and, in the most telling number of all, only 24% of respondents were confident their own favourite interpretation is actually correct. Sean Carroll, himself a many-worlds advocate, once published the interpretation poll spread under the title "The Most Embarrassing Graph in Modern Physics," and he meant the embarrassment institutionally. A century after the theory's birth, the people who use quantum mechanics every day still cannot agree on what it says about reality. Keep that in view whenever tonight's argument felt vertiginous. Every step of the immortality debate happens inside an interpretation that most physicists do not endorse. Wrestling with a probability concept its own advocates are still deriving. This is a live frontier, not settled ground, and honest cosmology names the difference. Why has a century not settled it? Because the interpretations are, so far, empirically identical. Every one of them reproduces the same predictions for every experiment anyone has designed, which is precisely what makes them interpretations rather than competing theories. The disagreement lives entirely in what the formalism means, and meaning does not show up on a detector. Could that change? Possibly, and the frontier is genuinely active. Objective collapse models like the Girardi-Rimini-Weber theory predict tiny, real deviations from standard quantum mechanics, and experimentalists are hunting them with ever larger superpositions. If collapse is ever caught in the act, the branching picture dies overnight, and tonight's entire debate becomes a historical curiosity. Until then, the choice of interpretation is guided by economy, coherence, and taste, which is why the polls look the way they do,
and why the humility in that 24% confidence figure may be the most scientific number in the whole survey. Does that uncertainty rescue the survival argument? Run the logic. The argument needs many worlds to be true, needs the mortalist reading of many worlds to be false, and needs the far future thermodynamics to be evadable, three nested long shots, the first of which currently polls at 15% among the people best placed to judge. A chain of maybes is not a doorway, it is a chain of maybes.
I said at the start that this channel would not sell you a mystery it could not pay for. So before the final weighing, one personal note. This is the part of the story that stays with me. Not the branching, not the vertigo, the discipline. A quarter century of extremely capable people handed an argument that flattered their own theory with the most desirable conclusion imaginable, and they took it apart instead, assumption by assumption, in public, with their names attached. Moravec glimpsed it, Marchall derived it, Tegmark formalized it, and then Tegmark led the demolition of his own formalization. Whatever else tonight has shown, it has shown you what intellectual honesty looks like at full strength, and that, more than any interpretation, is the thing physics actually runs on. For nearly 2 hours, I have laid the arguments side by side and mostly let them speak. That neutrality now ends, because the evidence is in, and the job of this final stretch is to weigh it, position against position, and say plainly what it supports. And as the weighing begins, pocket one last question next to the others, because everything tonight has circled it and only the closing minutes will face it directly. In the one perfectly idealized case, the case that never occurs in nature but is not forbidden on paper, where branching and an ending truly coincide, what should an observer expect? Hold it. It is the only survivor of the demolition, and it goes last. 3 positions stand for judgment. First, the immortalist reading. Awareness is constrained to track surviving branches, so subjective continuation is guaranteed. Second, the mortalist reading, held by the mainstream of Everettians. The branching is real, but expectation must follow the born measure, and you should anticipate the ordinary odds of an ordinary life. Third, the non-branching interpretations, Copenhagen and its rivals, under which the question never arises at all because there is only one world to die in. Weigh the immortalist case first, and weigh it fairly, because it is not empty. Its foundation is a genuine theorem of the branching picture. The linear evolution of the wave function really does guarantee that successor-containing branches exist after almost any event. Its selection effect insight, that experience cannot be found where there is no experiencer, is a near tautology with real philosophical force, and its pedigree runs through serious minds. But set against that foundation the 4 findings this video has assembled. 1. The decoherence numbers. The brain is a classical object. Branching completes 10 billion times faster than thought. The mental image of awareness navigating a fork is physics at the wrong scale, and the argument's intuitive engine does not survive contact with its own author's measurements. 2. The biology. Real endings are graded, not binary. The clean 2-column ledger the paradox requires does not occur in nature, and on the realistic continuum of branches, the experiencer-containing ones are overwhelmingly the ones in which you merely continue diminishing at normal odds. 3. The measure mathematics. Every road the Everettians themselves built to make probability meaningful, decision theory, the caring measure, self-locating uncertainty, leads to the same rule. And the rule says expectation flows with squared amplitude. The surviving trickle exists. It simply cannot claim your anticipation, any more than the lottery branch can claim your budget. 4. Even granting everything, the far future forecloses the prize. Landauer's flaw, the accelerating universe's temperature, the Bekenstein bound, and the proton's mortality mean no branch hosts unbounded experience. The claim was continuation without limit. Physics offers no venue for it. Count the card explicitly before the verdict, category by category, the way a referee would. The existence of surviving successors. Conceded to the survival reading, it is a theorem. The relevance of surviving successors to expectation. Mortalist,
by three independent derivations of the Born weighting. The physical realism of the binary fork, mortalist, by Tegmark's own decoherence numbers and by biology's gradualism. The identity of the survivor, mortalist, by Carroll's descendants and Zurek's fuzzy-edged patterns. The moral arithmetic, mortalist, by Weidmann's measures and Deutsch's exposed assumption. The far future venue, mortalist, by Landauer, Bekenstein, and the proton itself. The idealized simultaneous case, unresolved and awarded to no one, held open with Wallace's concession pinned to it. 6 categories to one side, one genuinely open, none to the other. Verdicts in science are rarely this lopsided while remaining this interesting. Now weigh the mortalist case and notice its quieter strength. It wins on the immortalist's own terms. It does not need to deny the branching, the successors, or the selection effect. It needs only the theory's own probability rule, applied without special pleading, and every one of its 4 supports comes from inside the branching camp. Tegmark's numbers, Sebens's simultaneity argument, Weidmann's measures, Carroll's descendants, Papineau's symmetry, Deutsch's exposed assumption. When a position defeats its rival using only the rival's own equipment, the victory is the durable kind. The verdict of this channel, stated without hedging, the evidence supports the mortalist reading. If many worlds is true, you should expect exactly the odds your doctor quotes, the branching notwithstanding. And if many worlds is false, as the majority of the field's polls would have it, the question dissolves entirely. On no live interpretation of quantum mechanics does the physics promise continuation. That is the resolution, and it is not a disappointment. It is the sound of a beautiful, dangerous idea being handled correctly. But a verdict is not the end of this story, because 2 genuine treasures survive the demolition, and refusing to name them would be its own kind of dishonesty. The first survivor is the reframing. Even with immortality dead, the branching picture forces a strange and permanent shift in how the continuity of experience must be described. Why does your awareness feel like an unbroken thread, tonight, across sleep, across anesthesia, across every gap? The classical answer was, because it is one thread. The Everettian answer is, because the feeling of threadedness is what any successor's memory reports, in every branch containing a successor, regardless of the tree's wild geometry beneath. Return one final time to the dashboard camera, the one that records only while the engine runs. Review its footage and you will find a perfectly continuous drive. Road, road, road. No gaps, no parking, no nights. The footage is not lying, frame by frame. It is structurally incapable of containing the stillness between drives, and so it testifies, with perfect sincerity, to a journey that never paused. Memory is that camera. It records only while the recorder runs, and then presents its unbroken tape as proof the recorder never stopped. The felt seamlessness of being you may be, in part, a selection effect, a property not of the world, but of where reports can come from. What does it mean that the strongest evidence you have for your own continuity is testimony from a witness that cannot, even in principle, report an interruption? That is not a promise of survival. It is something more unsettling and more valuable. The discovery that first-person certainty is a biased instrument, incapable in principle of registering its own interruptions. You cannot experience the end of your awareness, true, but as tonight has shown, that sentence is a statement about the limits of experience, not about the limits of endings, and confusing the two was the entire 200-year-old mistake, the paradox dressed in quantum clothing. The second survivor is the open case, so bring out the question you pocketed at the start of the weighing. The idealized scenario, branching and ending truly simultaneous, no delay, no gradation, the case nature never builds but paper permits. What should an observer expect there? Here, and only here, the field's honesty requires the admission, it does not know. David Wallace, the mortalist who wrote the definitive modern treatise on the branching universe, concedes on the record that precisely because endings are philosophically complicated, his objections fall short of being a knockdown refutation. Papineau maintains the symmetric expectation. Sebens's argument, by his own construction, goes quiet exactly at zero delay. And as recently as 2025, philosophers were still publishing on the costs of each answer in the professional journals. The dispute is not about the wave function, whose behavior everyone agrees on. It is about whether the phrase, "What will I experience next?" has any determinate meaning when some of the candidates for the next experience simply are not there. That is the honest edge of tonight's topic. Not a hidden door to continuation, but an unresolved question about what expectation itself means in a universe that can contain several of you, and then fewer.
And beneath that edge lies the deeper one, the boundary this channel always names plainly. Physics can count branches, weigh measures, time decoherence, and price computation. What it cannot yet do, on any interpretation, is say what experience is, why there is a first-person point of view at all, or what, ultimately, the ending of one amounts to. Tonight's verdict is a verdict about the quantum argument, and only that. The equations do not underwrite continuation. Whether anything more can be said about awareness and its endings is a question that stands beyond what these measurements can settle, and the honest position, the one this channel holds every time the topic arises, is to say so and leave it open. The science resolves, the ultimate question remains what it has always been, open. Which returns us, one last time, to the man in whom the whole story is written small. Hugh Everett III, by his biographer's account, may have privately believed his tree guaranteed his point of view could not end, though his biographer Peter Byrne doubts even that, observing wryly that the argument's only sure promise is that the majority of your copies will not make it, hardly a rational comfort. Everett built the most audacious structure in the history of physical theory at 26, was dismissed by the field's grandees, walked away, and spent decades applying game theory to weapons planning, while his idea slowly conquered a following he never courted. He did not live to see the polls where his interpretation finally outscored some rivals, or the decision theory renaissance his framework enabled, or, for that matter, this video. He was 51 when his heart stopped, in every branch any of us can reach. If the argument he allegedly trusted is right, something continued somewhere, at a measure too thin to matter to anyone who loved him. If the argument is wrong, as the balance of tonight's evidence says, then what remains of Everett is what remains of anyone, consequences. And his are enormous. Either way, notice the shape of the lesson, because it is the same one the mathematics taught. What a person leaves in the branches that others can reach, the work, the ideas, the people changed, is the only inheritance whose measure does not thin. Two questions tend to linger after this topic, and they deserve direct answers before the close. First, if the branches are real, is there a version of me who chose differently, who took the other job, said the other sentence, lived the other life? On strict Everettian terms, branching follows quantum events, and the connection between quantum randomness and human decision-making is genuinely murky. The honest answer is that the theory neither promises nor rules out variant lives, and any confident claim either way outruns the physics. But notice what the measure discipline you have learned tonight says about the question's emotional weight. Those branches, if they exist, are as unreachable as the maverick ones, carry no message for this one, and change nothing about the only life your choices actually steer. The tree, whatever its shape, is not a mirror to gaze into. It is, at most, a reminder that this branch is the one you are writing. Second, how should I feel about the copies, if copies there be? Here the mathematics offers, unexpectedly, something almost like counsel. Every version of you shares your entire past up to each fork. Whatever you build, learn, repair, or set in motion before a fork is inherited by every descendant on every side of it. The one investment that pays in every branch is the person you are before the branching.
Physics rarely hands out advice. When it does, it is worth taking. A last practical word, spoken directly, because this topic touches ground where confusion can cost. Nothing in tonight's 2 hours is a reason to treat any risk, any illness, or any despair differently. That is not this channel being cautious. It is the unanimous, on-the-record position of every physicist quoted tonight, including the argument's own author, and it is what the equations themselves say once the measure is counted honestly. The physics of branching, correctly understood, hands back the plainest human arithmetic. Every future is weighed, every care is real, and the people in your branch are the ones your choices reach. If tonight's ideas have been heavy company, set them down with that. So let the whole architecture stand in view as one shape. The wave function, branching without end, weighed by the Born rule. Decoherence building worlds and, in the same stroke, sealing consciousness far above the splitting. The measure problem, the field's deepest embarrassment, resolving into the very mathematics that dissolves the survival claim. The far future, priced by Landauer and bounded by Bekenstein, closing the venue. And threaded through it all, the one modest, extraordinary discovery this topic leaves permanently in your hands. First-person experience is a biased witness, structurally incapable of reporting its own absences, so the feeling of unbroken continuity, tonight and every night, is evidence of almost nothing. The honest map of reality has to be drawn from outside that feeling, with equations, with measures, with tanks of water under mountains, patiently waiting out the dark. If you found value in this exploration, consider subscribing. It helps these deep dives reach more curious minds. Tonight then, the experiment you cannot avoid. You will lie down and awareness will begin its nightly dimming, and somewhere in the fade there will be a last moment you never catch, exactly as there has been every night of your life. The quantum immortality argument promised that this unwatchable edge was a doorway physics holds open forever. The physics, examined to the bottom, says otherwise. The edge is simply where the witness stops writing, while the world, in every branch, carries on by the weights. You cannot experience the end of your awareness. That much is true, and it was always true, and it never needed quantum mechanics. What the equations add is the harder, cleaner gift, the reminder that reality is not obliged to be shaped like the view from inside it, and that the truest things about us were never the ones only we could see.